Hunter's going to explain the bell ringer. Let's pay close attention so that way, in case anyone made a mistake, make sure whenever you're discussing it that you say like exactly what you did out loud because they can't see what's written on the board. All right, go ahead.
Okay, so I wrote the formula down because like it makes it easy and so like I just like y minus 8 because it's y on there and whatever. Then the slope is right there for n. And then times x minus x1, which is 6. Multiply this by the terms that you can use. Got negative 4 or something. I think. Yeah, and then I added 4 on both sides to cancel that thing out. So then it'd be y equals 2/3 x plus 4.
Okay, awesome. Parker, tell us, do you agree or disagree?
I agree.
Allison?
I disagree.
Okay.
The 6, no wait. Because 2/3. Never mind, I guess I didn't know that. I guess
On these calculators, I would do parentheses and then 2 divided by 3, close your parenthesis, and then times the negative 6.
Well, I put my 6 for the x was and my x was 6 was on that parenthesis.
Oh, okay. Yeah. All right, so it should be negative 4, and then if you added 8, you would get positive 4. So y equals 2/3 x plus 4. Very good. All right, yeah, so it is y equals 2/3 x plus 4. What questions do you have for us on the bell ringer? Yes. All right, you can go ahead and write your names on it, pass it to the front row, pass it to the right. And then get out your notes from yesterday so we can finish those.
We have a worksheet today. And it's just like this, like we don't have to work anything out.
You like the only like actual work you have to do is like rearranging it. All right, now did we finish this problem here?
Yeah.
The 15x minus x cubed plus 3?
That was the last one that we did.
Okay, and we did all of it, right? Okay. All right, so let's move on to the next one. So yesterday we were talking about polynomials. First thing we were doing was putting them in standard form, and that goes from biggest exponent to smallest exponent. The degree is the biggest exponent of the polynomial. So it's the biggest exponent, the biggest power, okay? The degree name, we had constant, linear, quadratic, cubic, quartic, quintic, and then after that, after 5, you just say 6th degree, 7th degree, 8th degree, and so forth. For a polynomial name, if it has 1 term, it's a monomial, 2 terms is binomial, 3 terms is trinomial, and then after that, you just call it a polynomial. Okay? Standard form, like we said, is in order from exponents, in order from biggest to smallest. The leading coefficient, that's the coefficient that's in the front of the number when it's in standard form. So like this one, in standard form, the negative x cubed would go first. So my leading coefficient's -1. And the constant is the one that has a degree of 0, so there's no variable. So that would be +3. All right, so let's do the next one. So first thing I need you to do is fill out the expression -8 plus 9x squared minus 2x. -8 plus 9x squared minus 2x. So first thing we need to say is the degree. So you would need to say what the degree is. Let's see if my pen's going to work. All right, Hayden, what degree would you say this polynomial is?
2.
2, and how did you figure that out?
The squared on line x.
Yeah, this square here, that's the biggest exponent, so that's a degree of 2. Brandon, what would be the name for the degree? Quadratic, perfect, and we remember those from chapter 1, function families. Anytime it has a squared, it's quadratic. Anytime the biggest exponent is a 2, it's quadratic. And then the polynomial name, that's based on how many terms there are. Cheyenne, how many terms would you say are in this polynomial?
3.
And so what would that be?
Trinomial.
A trinomial. So that's a trinomial. Tri means 3. And now we need to arrange it in standard form. Okay. Cheney, how would you write this one in standard form?
9x squared minus 2x minus
Perfect. So it goes in order, the exponents from largest to smallest, 2, 1, 0. And then the leading coefficient. The coefficient is the number being multiplied by the power. So it's the number in the front. So that means like 9 times x squared. 9 is a coefficient. -2 times x. -2 is a coefficient. Austin, what would you say the leading coefficient is?
9.
Perfect. And the last thing is the constant. That means it has no variable with it. Adriana, what would you say the constant was? 8. Now, what's the sign in front of it?
-8, sorry.
-8. Perfect. Yeah, so don't forget the sign in front of it. So that would be -8. Good job.
How do you know the constant again?
It does not have a variable with it in that term. It's the term that does not have a variable. Okay. All right. Oh. Let's see what that says. Oh, down here, they changed it a little bit. They updated it. All right, here's number 4. -3z to the 4th power. -3z to the 4th power. Rebecca, what would you say the degree is for this polynomial?
4.
4. And Hunter, what would be the name for a degree of 4?
I did not say that.
It's kind of like quarter, but
Yeah.
instead of it's it. So quartic. And what about the polynomial name? That's based on the number of terms. Allison, what kind would you say it is?
The polynomial?
Yeah.
The monomial?
Yeah, there's one term, so it's a monomial. And then how would I write that in standard form? You can go ahead, Allison. Yeah, you just leave it like that. It's one term, so there's nothing you really have to do. So it's just -3z to the 4th. All right, Adriana, what would be the leading coefficient? Good job. And Kaden, what would my constant be?
-3.
Not just
No, because it doesn't have to say probably 0.
perfect.
So if there's not one going on, you just put 0.
Yep, if there's not one, just put 0.
So a constant is something with no variable. What are they able to have
So is this
exponents?
what the,
Yeah, like if you had 4 squared, you would just evaluate that. 4 squared would be 16. And so you would just simplify it.
is this what the worksheet's gonna be today?
Yes. Yep, the worksheet's pretty much exactly. Now, there is some vocab at the beginning, like there's vocab words at the beginning, and then it's pretty much just what we did. There's one part that says determine if it's a polynomial. If not, explain why. So remember, I gave you at the beginning, I told you what a polynomial was, and I gave you some examples of non-polynomials and why they were not polynomials. It was at the beginning. I went over it yesterday.
Okay.
I'm not sure if you wrote it down. All right, number 5. Does this one say guided practice? Okay. All right, this one you're going to do with your partner. Kaden, can I get you to move over there and you and Brandon be partners today since both of your partners are gone? All right, so here's number 5. First, you need to fill in the expression 3 plus 7a squared. And you need to work that out with your partner. Kaden, And what did you and your partner get for the degree? I'm sorry, say that again.
2
And what about the degree name?
quadratic.
Okay, and then Hayden, what did you and your partner get for the polynomial name?
Binomial.
And Hunter, what did you and your partner get for standard form?
7 a squared plus 3.
And Allison, what did you and your partner get for the leading coefficient?
7.
And Austin, what did you and your partners get for the constant?
3.
Perfect. All right, let's go to the next one. All right, write this one down and try this one out with your partner. 16n to the 7th plus 6n to the 4th minus 3n squared.
So if I come in, I get.
All right, Rebecca, what did you and your partner get for the degree? You said 7. Parker, what did you and your partner get for the degree name?
7 power.
You could say 7th power, but we want to say 7th degree. Just say 7th degree. All right, Brandon, what did you and your partner get for the polynomial name?
Trinomial.
Hey, Brianna, what did y'all get for standard form?
The exact same equation that was given.
Perfect, yeah, so the exact same expression, everything's already, all the exponents are already in order from least to greatest. Cheyenne, what did y'all get for the leading coefficient?
16.
And Cheney, what did y'all get for the constant?
0.
There you go. What questions do you have on the notes? All right, so, can someone tell me what page number these notes are? 30, page 30. All right, so it's page 30, 7.1, Introduction to Polynomials. And then you're going to get your worksheet today, and I forgot to change, because in the old algebra book, this was chapter 12, and in this chapter, or in this book, it's chapter 7. Keep your desks like they are. So I forgot to change it to 7.1 worksheet, so whenever you get your worksheet, change the 12.1 to 7.1. Numbers 1 through 7 are definitions. Our vocab words and definitions, you match the definition with the term. If it's a term you're not sure about, you're more than welcome to look up the definition of that one on like either Big Ideas or Google, whatever you need to figure out what the definition for that is, because different books use different explanations or different definitions for terms. 8 through 11 says determine whether each expression is a polynomial. So you'll say either yes or no, it is or it isn't. But if it's not, you got to explain why not. And then on the back, 12 through 15 says determine whether the polynomial is a monomial, binomial, or trinomial. And then state the degree and the degree name. So 3 things on 12 through 15. And then 16 through 21 says write the polynomial in standard form. If it's already in, if none of them are already in standard form, so never mind. So write each polynomial in standard form, classify it by its number of terms and by its degree, identify the leading coefficient, and identify the constant. You'll have the rest of the class to work on it. If you don't finish, it's homework. Work with your partner. Make sure you discuss the questions with each other, so that way you know. Make sure you both understand it. Use your notes. Just a second. Thank you. That depends.